Welcome back to another episode of Discovering Disruptions in Tech. We've got an interesting one for you. This week we have Jeremy Rossbach, is that correct?
Rossbach, yeah.
Rossbach, who's the chief technical evangelist at a massive technology company. I'll let you reveal that as we go along here, but I want people to concentrate on the topic. We're going to talk about network observability, which I think we're both fairly passionate about, Jeremy.
Yes, definitely.
So let's set a little bit of the stage, right? Historically, we've run networks inside the four walls of our data center, the four walls of our business, clearly defined things with moats and spikes and pitchforks and dragons in the keep and alligators and whatever else we could pack into the moat. But we really had a clear understanding of what the boundaries were, right? And we controlled those boundaries. So if we decided we didn't want the boundary to change, we had the ability to say, cool, the boundary doesn't change. But a few things have happened in the last 10 years that have significantly altered that. What's the change? What makes this hard? What makes this complex today?
Yeah. So just like you said, and I usually use the analogy when I was running data centers, it was basically just headquarters, T1 to branch off every packet, every user, every app, every hop. I do like your dragons and moat and castles analogy as well. But yeah, those were the good old days, right? We controlled everything and that was our kingdom. But, listen, I hate bringing up the pandemic again and again, but it over the last few years, it's really, really changed what that network path looks like now, right? Hybrid work, SD-WAN, SASE, cloud migration and adoption, SaaS adoption. All of that, which I know all of my customers that I talk to are in the middle of, it just basically changes what that network path looks like now. It is not just a few hops. I mean, me and you recording this right now, God knows what that network path looks like. God knows how many ISPs and backhauls and transit networks we're going through. Talk about, how resilient is my Wi-Fi? How resilient is your Wi-Fi? And that is the core problem we see with a lot of Broadcom's customers is they've lost the keys to the kingdom. They've lost that visibility into what does every hop look like? Who are the users? What are the apps? Where's the packet loss occurring? It is definitely challenging for folks out there today.
Yeah, without a doubt, right? So let's start with the kind of logical place to start, which is tools, because we're really good at buying tools, waving magic wands, and wondering why the pumpkin is still the pumpkin and not the beautiful carriage that's going to carry us to the magical fairy party, right? So let's start with tools. How do the tools need to change, or what is the tooling that kind of helps us kind of start down this path of wrapping our arms around the problem?
Sure. Listen, there's a lot of great tools out there. A lot of vendors build a lot of great monitoring and observability tools for their specific flavor of technology. But listen, I don't know a lot of the customers I talk to that have one vendor's technology in their data centers. And now, as we talk about the new network path being outside of the data center, who knows what vendor technology that user experience is going across? So I think first and foremost is solutions need to be multi-vendor agnostic. They need to be able to play well with everybody. They need to be able to speak that vendor's language and speak this vendor's language. So I need to be able to monitor Cisco core switches and Juniper firewalls and you name it vendor. But you have to take it a step further. You need to then be able to take all those languages and normalize them into one language that the NOC operator speaks, right? That means being able to take all the data you collect from all those vendors and data. We could have 7 podcasts on just how important data is. But all the data that you collect from those vendors, normalize it, correlate it, clean it, and then present it to network teams so they easily and quickly see not only a global view of network health, and I'm talking in managed and unmanaged networks, those networks outside the four walls of the data center, but then also be able to dive deep to granular levels that the data can provide, like where's packet loss occurring? Did I breach latency over 20% of a threshold that I set? What's 3 months down the road look like, et cetera, et cetera?
Yeah, that becomes really complex, right? If you just think about the average enterprise, you probably have 25,000 to 75,000 devices in just a mid-size enterprise. We're not talking one of the massive companies that has, potentially tens or hundreds of millions of devices when it's all said and done. How do you take this problem and make it like something that I can fit into my brain? Because obviously I have to start thinking about things differently, right? In order to do that, I kind of have to be able to conceptually understand it, reconcile it. Like, how do you recommend I start with that?
So scale is always an issue, especially when it comes to growing network, especially when it comes to software defined, right? A banking customer that we work with, they are deploying they are managing 300,000 SD-WAN tunnels. Can you imagine the number of SLAs that are on top of that and the endpoints that are inside of that? Yeah. So what we do, or what is recommended, is that the vendors should handle the scale problem for customers, and how that can be done. Because listen, you and I know there's a shortage of skilled workers out there. I talked to one customer that had to shelve their SD-WAN deployment because the SD-WAN architect got laid off. We have to, as vendors, we have to make things simpler for network teams as the networks get more complex. When it comes to scale, and to answer your question, things like, listen, if you have 300,000 SD-WAN tunnels, that's going to create a lot of noise. That's going to create a lot of events. So alarm noise reduction, event correlation, device suppression. If this core switch that has 12 48 port blades in it goes down, I can't do the math, but however many devices are connect to every single one of those 12 blades and 48 ports, that's a lot of events that you're going to get inside the network operations center. So to be able to have advanced and patented and trusted algorithms to suppress that noise, correlate the events, and show you one root cause, not whatever 48 times 12 is. All these devices are down. It's really the core switch is down and you've lost connectivity to the rest. So being smart enough as a management vendor to suppress that noise, correlate those events, and show NOC operators what to focus on as quickly and easily as possible.
Yeah, and let's dig into that just a little bit, because on the surface, that actually sounds easy. Right? Okay, cool. Like, you can go to the first event. No, you really can't. You can do a data roll up. Nope, the data's not identical, so you really can't. Right? Like let's kind of talk through what are all the kind of stages of that, and then we don't need to get super deep, right? But then, like, let's define the problem, and then talk about what are the techniques that are used to find the root cause. Yeah, I don't need to know that 48 devices are disconnected. I need to know what the cause is. Okay, cool. The switch is off, right? It lost power, or someone opened the door to the data center, and we've now got loopback, and we just now found out that that's not configured properly, right? Or whatever it happens to be, right? So let's kind of talk through that a little bit.
Sure. So without getting too deep, because you're talking about patented algorithms that go back 30 years with us that I did not write, but are still trusted by our customers. A solution that is smart enough to be able to inductive modeling technology is what we call it. So to be able to discover a network, understand the relationships and dependencies of that network. This switch is connected to this router. This is connected to these services, et cetera, et cetera. Understand upstream and downstream network flows, and be smart enough when it's done this discovery and has had enough data to understand what's connected and how it's connected. So when that core switch does go down, it is smart enough because of the data and the time it's taken to analyze the network to be able to identify that the root cause is the switch and suppresses all the downstream events or downstream devices behind it, because it's understood the topology it's built and the relationships and dependencies upon each device, each interface as it connects down the line. What then happens is when we throw one alarm into our network operations dashboard, that doesn't mean that we don't let him know about all those suppressed events. They can be found within the alarm to say all these events built this alarm. But then what gets very critical, and you're talking about root cause, is that from alarm to diagnosis is where we get into data. So, some vendors collect 8 out of the 10 ingredients. Some collect 9 out of 10. We like to say we collect them all, because the more data you have, the more insightful information you can get to a root cause. So contextually, when that alarm comes in and we've discovered that the root of the outage is that switch, we still haven't found the root cause of what's wrong with the switch, to be able to click within the alarm and look at everything we know about that switch. I'm talking CPU utilization, memory, logs, performance, latency, packet loss, you name it.
Input voltage, health of the fans, speed of the fans, temperatures, all of it.
All the faults, all the events. And exactly, the more data you collect, the better the breadcrumbs are to the root cause. So we go from alarm to contextual data, because we aren't missing anything about that device. Now, for example, and it's been 15 years since I was running data centers, so forgive me if my technology names are wrong, but let's say some interface is flapping on a switch. Maybe it's some optical device, and you only are going to find evidence of that in the logs. So if you're looking at fault, you're looking at performance, you're looking at flows, you're looking at whatever, utilization, you're looking for a needle in a haystack, right? So if you're not collecting logs on that device, you're never going to find the root cause, or it's going to take you a hell of a lot longer. So data is what helps us find the root cause as quick as possible. And to be able to help our customers get from one or minimal clicks from alarm to diagnosis.
Well, and all of the data is required to find the cause. Some of the data will only give you the effect, right? It'll give you the cause some of the time, but all of the time, it will only give you the effect. Because if the data doesn't contain the data about the cause, to your point, right, then all I can do is still see the effect. And that's where the problem lies.
Yeah.
Cool.
Yeah.
It'll lead me directionally to a place that might work 95% of the time, right? But 5% of the time, I'm going to burn a lot of time looking for a needle in a haystack that doesn't have the needle I'm looking for in it to begin with.
Now, imagine that scenario when someone calls from home and says, I'm trying to do a WebEx, and the guy I'm talking to says that my audio isn't matching my video and my mouth. And in today's network path, how do you apply what I just said to the new network path of not managing any of that equipment, which is our network path here, right? From my home to my home wireless to my Verizon Fios here on the East Coast, God knows how many other backhaul or transit, up to the Google Cloud maybe, which is what my company uses, and then whatever you're using. How do you begin to even gather breadcrumbs, let alone follow them? And that's what we're excited about doing for our customers.
So what does that look like? Because to your point, right, I don't have the ability to configure any of those logs. I have the ability to capture data, but even the data that I capture, I kind of have to be careful of, because I don't control the network, I don't control the bandwidth, I don't control the availability, I don't, the number of things I don't control fill the checklist rather than the number of things I do control. So like, how do we look at the things that are outside of our network, right, in a way that's analogous to the stuff inside our network, while at the same time not throwing our hands up because of the things we can't see. Like, what should I be looking for? How should I be thinking about those things that are outside my network?
Yeah. So what we're doing, and we're excited to be doing, is taking the 30 years of network observability that we've been doing across fault, performance, and flow for some of the largest private and public networks in the world, and taking that same full stack observability and applying it to these unmanaged networks, like that network path I just told you about. Now, listen. Inside the four walls of the data center, we can find the root cause and run automation and fix things and provide recommendations and all that to fix. If you're not aware, Broadcom, probably talking 2 to 3 years ago now, purchased AppNeta. And AppNeta is a observability solution that is enabling customers to be able to see outside of the four walls of the data center. So AppNeta has monitoring points all throughout many of the major cloud providers. Folks can run it on their laptop. Folks run it inside their data center, wherever they think the network path may be for application delivery. So to be able to fill those visibility gaps, which now are what our customers are dealing with because the four walls have been broken and the user experience is now anywhere. We utilize this very exciting solution that I may say has kept us number one in the industry analyst reports from GigaOM for the Network Observability Radar. We're very proud to be named number one for the 4th year. And I really think it has to do with our ability to be able to apply the full stack observability solution that we've been doing inside the four walls of the data center and applying it outside. So when you have the ability to have monitoring points that can act as a user, let's say, anywhere in the world, and to be able to utilize those monitoring points to understand every single hop that a user is taking, I don't care where they are in the world, to be able to understand as it goes through this ISP and understand what BGP changes look like, et cetera. And then however many other ISPs out there that it may go to. And then finally, maybe it ends in a cloud environment. You know, am I getting logs and all the stuff that we would get from a data collected point of view from inside the four walls of the data center in these unmanaged networks? No. But am I getting an idea of which device along that network path that may be housed in Verizon, Comcast, CenturyLink, and is it breaching a threshold of latency, packet loss, you know, the 3 WAN, you know, jitter? Yes, we're getting that. So, you know, we call it mean time to innocence or mean time to insights. Not only are we able to find the root cause of a performance issue inside of an unmanaged network like an ISP, we can find the IP address and we can find the performance problem, you know, 50% packet loss, you name it, whatever it is, and take that information to the ISP. I'll give you a quick example if I can. You want to go?
Okay. I was just going to say the one thing that I want to kind of highlight there is the other thing you can do is immediately eliminate the 35 of 36 points that don't have a problem.
Yes.
Right. So it's not only here's the path, here's all the information about the path, but also all of this looks good. Ignore this for right now. Concentrate here.
Yeah.
Focus your attention here.
And it's kind of funny because, you know, as a network guy, you kind of want a lot of data to be able to pinpoint what you need to do next, right? Step 1, I ping. Step 2, I trace route. And then you want data to be able to show you exactly what to work on. Now everyone's excited to have data that lets them see what they don't have to work on. It's not my problem, you know? For example, so one of our customers recently, they host financial data for other, so consider them like a cloud provider for financial data, and they host it for other financial customers. And one customer is calling him every day, your network sucks, and I can't use this app, and blah, blah. And, you know, the network engineer inside of the financial data center couldn't figure out what the hell was going on.
Sure.
finally threw an AppNet, a monitoring point inside of the customer's data center, and within minutes told him that you have a misconfigured F5 load balancer. Don't ask me the details, but again, mean time to innocence, maybe the detail was half duplex. I mean, who knows? Mean time to innocence is, hey, it's not me, it's you. I can tell you this. Mean time to insights is, your firewall, your load balancer is set to half duplex. It's a game changer. It's an absolute game changer. And, imagine the triage time improvements, and if I was going to spend 4 hours looking for that network needle in a haystack and finally realized it was the client's issue, oh my God, how many hours did I spend when I could have been doing something maybe a little more innovative?
Super. That's seems super valuable, right? Mm-hmm. It seems like this is the logical direction we should be going, what we should do. It does also seem like a lot, right? We do experience kind of interface fatigue, alert fatigue, blinky light fatigue, mm-hmm. right? This kind of psychological, okay, time to get started, right? Mm-hmm. I'm sure the platform does everything possible to reduce that, but there's a emerging technology. I mean, we're all talking about it all the time, mm-hmm. right? Let's kind of shift the conversation to the role we now see, now that we understand the problem. What is the role that we see, or you see, AI playing in helping us kind of overcome a bit of the fatigue, overcome a bit of the kind of learning barrier, overcome a bit of the, that kind of retroactive thing that we always have, which is, hey, we figured out the root cause, and the root cause was we weren't watching the thing we should have been watching, so we weren't aware of the thing. Mm-hmm. I think AI has the ability to help us with all those. Let's talk about that for a minute.
Yeah. Listen, AI kind of scares me. Network automation kind of scares me. I mean, it's really, you and I know, hands on keyboards, this is my kingdom. This is my network. I know what to do when things are broken, and handing that over is still difficult, I would assume. But I think we have no choice. Networks are getting more complex. When I was running networks for the Veterans Affairs and T. Rowe Price in Baltimore, you didn't have to be a coder. You didn't have to know Perl and all that. Things are much more complex. SD-WAN, automated routing. Automated routing, that sounds so scary, So we use the slogan, trust, but validate. And that's what we do a lot with our solutions, is validate that these automated procedures are doing what they should be doing and when. But I think we don't have a choice. There's a skills shortage. There's a staffing shortage. I've seen the data showing it. I've talked to customers, like I mentioned, shelving their SD-WAN because folks got laid off. We really don't have a choice. So I think we're at a tipping point where, we're reluctantly saying not everything has to be manual, anymore. So,
can it? I think the other question is, can it?
Yeah.
Right. Like as we move outside the walls of our enterprise, we go from managing layer 2, mostly 3, a bit of 4 within the network team, to 7.
Yeah, isn't that crazy?
Right. And so if you thought the skills, right, who would have thought the networking team would be at 7?
I know.
If you thought the skills that worked for you at layer 1 and 2 and 3 were going to benefit you when you hit 7, like that was going to be an easy translation. Oopsie.
Yeah.
Right. Not to mention the quantity of feeds, right, that we get containing data that doesn't really fit into how we think, right, to create decisions and actions that are made on something that exists in a layer we no longer have control over. And this isn't in addition to layers 2, 3, and 4. This is mostly a replacement for layers at least 2 and 3. Right? Because any routing table information you get is likely made up.
Yeah.
You know what I mean? Like it's likely an incomplete translation of information to make it seem palatable, but it's not really correct and
changes
inclusive
on the fly.
Right.
Yeah.
Right. It's not reliable. It's not all of those things. Right. So
Yeah,
So
let's talk. I want to talk use cases. Like, I only know a few because it's so early and it's scary to imagine what AI is going to do for networking. But, I know a few. And I may have mentioned this already. Hopefully, and especially, it's all about the data, right? It's all about collecting the data and applying the algorithms to the data correctly and getting it to learn. The more data you collect, the more the smarter the algorithms are. So when I walk in the morning and I say, hey, knockbot, I should, that's not really good. I should trademark it, but hey, knockbot, where should I focus my attention this morning? Or, hey, knockbot, Seattle users seem to be complaining. What's the root cause of the issues? And he should be smart enough, or she or the robot should be smart enough to look at the data, collect it, and say, listen, for the last 30 minutes, we've seen packet loss over 30% on this device in this ISP network, even, The other thing is, and these are real use cases that Broadcom is working on. Now, we all know Broadcom is a chip maker, very proud to be a chip maker. And we've been recently releasing AI embedded chipsets. And they're doing amazing things. Some things they're way over my head, but I will know some of the use cases that we used to demo a year or two ago are this. No longer will the monitoring system capture the data and do the work anymore. It's the chips. As these packets traverse over these very intelligent chips, they take a snapshot of, the header, enough information to be able to dissect right on the chip, let's say, packet loss. Now, listen, packet loss in your and my days was mirroring a port and looking through all the data and wondering what 60 of the codes it could be, the error codes that it could be, and where is it happening. These chips are so smart now that they're able to identify the source of the packet loss, the reason for the error code, the reason for the packet loss, the application that was traversing, the user or users that was impacted, you name it. So what took me and you hours to mirror and dump all that data and DPI is taking seconds. And then the chips then send that data to the MOM or the network operating system and says, an alarm says packet loss on this device with this error code affecting these users for the last 20 minutes. Another example, network congestion. A lot of our financial customers who do a lot of trading, right? You can imagine the millions of dollars that are transacted within seconds or milliseconds at these financial institutions. So network congestion is the devil for these folks, right? So to be able to understand congestion, we call it buffer statistics tracking, to be able to understand how congested these network queues are, on what device, where, within milliseconds, because our AI embedded chipsets are obviously smart enough, optimized enough to handle a large amount of data, apply the algorithms to it, and say this queue, this buffer is congested above 70%. It's causing latency for this application, and you get the point. And it just sends that information to the network management system. Listen, down the road, the network management system may just be a dashboard showcasing what the chips are telling it.
Sure. It's interesting to me that 40 years ago, we built dedicated ASICs like crazy, right? Compute was really expensive. We had no spare compute. And so we built ASICs into everything. Our storage controller had an ASIC, our video controller, like everything had an ASIC. And we didn't really do a ton of work the way we do now, right? Like the amount of work we expected those things to do wasn't heavy enough that the second we got to the point where Intel and AMD were producing spare compute cycles on a consistent and overwhelming basis, and our servers went from 70 to 100% utilized to 3 to 17% utilized, all of a sudden we went software-defined everything, software-defined everything, software-defined everything. Right? And we started leveraging that spare compute to drive our unit cost down on some of these things, to drive our complexity way down.
Yeah.
Was the other advantage, right?
Mm-hmm.
And now it feels like we're kind of moving back in the other direction a little bit with more kind of dedicated processors, right? We've got our TPUs, our GPUs, our DPUs, our whatever PUs that I'm just simply not, hip enough to stay on top of. In addition to the CPUs, and so it feels like we're kind of going back the other direction.
Well, think about where all the workloads and the consumption and the computations are being done now. They're being done in the cloud data centers and the hyperscalers, and we've moved all those workloads out to them. And I wouldn't say all of our customers have adopted these late and great AI enabled chipsets, but I will tell you the hyperscalers are, because they have no choice. They're marketing AI. They sure as hell need to be able to support it.
Well, I think that's an important thing for the listener to understand, right? As we talk about this kind of shift to back to custom silicon in some use cases, we're also talking about a shift of the responsibility of managing that custom silicon, right? It is unlikely, like that's not going to fall to you as the end user by default. You can absolutely build data centers with these things. You can absolutely run these things. I mean, there's a supply chain issue, right? There's an availability and scarcity issue, but we'll eventually overcome that, right? However, you can also opt not to. You are not forced to do it.
Yeah.
You can use the hyperscalers to take on the complexity. Whereas before, you would just not have the capability.
Yeah.
Now you can have the capability without the management responsibility. And that's an important distinction for those who think we're just shifting back to what we did before, right? And so there's kind of today, there's a model for that, right? And I don't mean an AI model, I mean an operating model, right? You can be responsible for as much or as little of turning the dials and turning the knobs as you would like to, and still get a full level of support all the way through the chain. I think that's a distinctive difference that we've not had in the past, right?
And the important thing there is, if you want to dial back what you're owning, right, and you hand off it to cloud and hyperscalers, that doesn't mean you still don't need to know what they're doing and how it affects your users. And that ties it all back to observability and full stack monitoring. And yes, I'm giving you everything, but I don't trust you, right? So I want to know what you're doing with my data. I want to know how my users are using your network, and I want to know how your network is performing. So when they call and complain to me, I have enough information to say, you're right, it's me, or it's you.
Right. Very distinctly. And both sides of the call need to be able to do the same thing.
Yes. And I was just talking to Telecom in Ireland, who is excited about the AppNeta solution for its mean time to innocence, because they get hit on their SLAs so much that they don't have the ability to prove it's not them. So all they want is the ability to say it's not us, it's you with AppNeta, and they're happy. So yeah, it goes both ways. Telecoms want to prove their innocence, and so do the enterprises using the telecoms.
Right. And so that actually brings up a kind of a buyer quandary, right? Or some advice. When you are shopping for your telecom, your network provider, your hyperscaler, your whatever, right? Your company to manage a thing you no longer control, have a conversation with them about their maturity in the observability space. Right? You don't want a mismatch there where you turn to your telecom and go, hey, look, I've got my observability, and it says the problem is yours. And they're like, what's observability now? Right? Sure, like you'll probably get a bill credit. That'll probably ramp up your bill credits, but it won't help with a mean time to repair. Right? It won't help getting that ticket resolved quicker. It won't help with all the things you actually need, which is to get the business running.
Yeah.
Right. And so you want someone that's a little bit more mature than you, I think, rather than the other way around.
It's funny you say that, because without mentioning names, one of the big hyperscalers and cloud providers have come to us for the AppNeta solution to be able to offer that as a service. Listen, if you're giving us everything and you want us to be your network provider, we want to provide you the visibility you need to make sure we're doing our job right. So it's very exciting to see these very large cloud providers utilize the same solution that we want our customers to utilize because they see the value in proving innocence or just staying resilient.
Sure.
And you'll hear an announcement about that anytime now, but it's amazing when you open up that visibility to be able to see beyond the four walls of your data center. I mean, Howard, who would have thought? I know it's crazy and I shake my head, but I never would have thought that when I was running data centers that 10, 15 years from now, no packets would be going through my data center anymore from my users. It is insane. And it's kind of scary. And like, what do you do? I'm a network engineer of a network I don't own.
Yeah.
I mean,
Right.
Yeah.
I mean, I managed large data centers, right? I had a 25,000 user data center that had a 31-story building built on top of it, and they anchored each other, right?
Yeah.
I at that time we didn't talk about cloud, wasn't a thing, right? We centralized to things like mainframe clients, or big servers, right? Like, I mean, in fairness, at the time we were still running a lot of NetWare, out of Novell.
Yeah, I remember that GroupWise.
Right. But nonetheless, right?
Yeah.
We didn't think about, hey, what does a state look like where there is no more data center we control? Oh, you mean an outsourced data center? Like we use a data center provider? No. Like none of that exists. Right. We never have we're not going to have another conversation about a 2U box to buy. What does that future look like?
So let me tell you a story, because I'll follow it with what is the reality now, which I'm sure you'll agree with me. So, wait, did I already tell the story about my kid and her bumpers? All right, I didn't. So, all right. So listen, I tell this story when I'm on stage. My kid, God love her, 24 years old. I've already replaced 4 of her bumpers. Okay. I expect the 5th is coming any day now. And I'm going to say to her, you know what? You're calling the insurance company, you deal with it. But I bet you, Howard, that insurance agent is not in an office. She's at home like me and you right now. And her network path does not look like the network path you and I knew 15 years ago. Corporate office, T1, branch office, blah. That network path looks insane. But if that insurance agent says, I'm sorry, Jillian, but I seem to be having ISP issues and I can't get to the claims app in AWS, that can't happen. You know why? Because even though we're network engineers of networks we don't own, we're still responsible for the user experience. There is not this, sorry, it's running along the ISP. It's not even entering our data center. That can't be a reason for customer service. IT needs to, you still own the experience, whether you own the infrastructure or not. And that is what we are very excited to be doing for our customers, is providing them that visibility so they can troubleshoot a network they're not a network engineer of.
Right. And let's be honest, right? The agent's not going to tell Jillian it's my ISP or a problem with AWS. They're going to say, I don't know, the claims aren't working, you got to call back.
Yeah. Can you call me back while you're on the side of the road in trapfic?
Right.
Yeah.
Right. Like they're going to
we're switching insurance companies.
Right. Well, this has been wonderful. I got one final question. We've covered a lot. We've talked about a lot of things. And again, it can feel a little bit overwhelming. So if you were to give 3 kind of next steps or pieces of advice or words of wisdom to the audience, what would those 3 things look like? If it's 2, if it's 5, it's fine.
Yeah. Listen, network observability is a buzzword. I'll be happy to admit it. What I believe makes sense is to start with the low-hanging fruit. Don't try to boil the ocean. You don't need to be building knock bots and all that right now. You need to reduce the alarms and the noise in your knock. You need to be able to unify fault, performance, and flow in one dashboard and get rid of the rest of the tool sets, or at least not use them as moms. You need to be able to have a solution that can give you visibility outside the 4 walls of the data center. And I would say, because we've handed over the keys to the kingdom to these hyperscalers and cloud providers, you need to start implementing this trust but validate. And what I didn't mention about our solutions is the fact that it can do active and synthetic testing to be able to simulate at very low packets, small packets, network traffic. So I can say, did I architect this SD-WAN solution correctly? Am I seeing any bottlenecks along every single hop? If I am, let me optimize it before I put it in production. When it's in production, continue that active testing to make sure nothing's going wrong, and continually trust but validate. But listen, organizations going to save a lot of money by just starting with that low-hanging fruit, right? Alarm noise reduction, unifying of what you're looking at, faster triage. It matters when you can reduce 4 hours of triage time down to 4 minutes. It really does.
Yeah, I mean, the more proactive we can be, also the fewer incidents we'll have that are true disruptions.
Yeah.
Right. Impact a few users, fine. Impact the whole business, not fine at all. Right. And so if we invest early, we invest smartly, we can generally find, identify, and remediate those things before they're problematic. So really good advice, Jeremy.
Thank you.
This has been wonderful. Thank you so much for joining us. How can people find you?
Yeah, check me out on LinkedIn, Jeremy Rossbach. And the best way and easiest way to find me is my own podcast, The NetOps Expert. I hope to have Howard on soon, but check out The NetOps Expert where you get all your podcasts. We talk everything networking like we did here, and I've really had a good time. This was a lot of fun. Love to be back.
Yeah, it was great for me too. We'd love to have you back. So
Good.
This has been another episode of Discovering Disruptions in Tech. Please like, subscribe, share, do all the things. If you'd like to be on the podcast, reach out. If you've got a guest, reach out. If you've got a question for a podcast, we do pay attention, and we'll try to either answer your question or get it back to the guest that we had. So yeah, this has been another great episode. We'll see you again on the next one. Thank you.